Are you ready to look at the fundamental theorem of calculus this morning? So I just want to remind you guys that our objective for the next few days is simply just to review for the AP exam so that you will all make fives. Let's recall the fundamental theorem of calculus. Now, because the whole AP exam this year is calculator active, you may not need this as much, but you do need to show it in your notation. So you have to remember that the fundamental theorem of calculus works on continuous closed interval functions. And what we do to find it is we find the antiderivative of f of x evaluated at b, and then take the antiderivative evaluated at a and subtract the two. Now, we also remember the fundamental theorem of calculus part 2. And it's quite likely you could have a free response on this question. So remember, in order for the fundamental theorem of calculus part 2 to work, your bottom interval has to be a constant. Your top interval and your derivative must match. And then if that is the case, then all we do is simply replace x into our function. Whatever our function was, we just replace it with x. Now, if x has a derivative other than 1, we have to do this and then multiply by the derivative of x. We call that using chain rule. So let's do a couple examples. What I want you to do is I want you to pause the video and try these on your own, and then come back when you're done and I will give you the answers. Okay? So this first one, we see that pi is a constant, so we're good. However, we're going to have to take the derivative of pi x. So we're just going to replace pi x with with t squared. So, and then take the derivative of that. So we get cosine of pi x quantity squared. And then we take the derivative of pi x, which is pi. So our answer should be E. Then for the next one, we notice that our lower limit is not 0. So we have to replace it. We have to remember a property. We can exchange these, but what is the condition? How can I just do that willy-nilly? I have to multiply by -1. So once I do that, I'm going to do the same thing I did before. I'm going to replace t squared with sine x. So that would be here. So that's either this one or this one. Well, it's all of them except for that one. And then I have to remember to take the derivative of sine x, which is cosine x, and then make it negative. So my answer is B. Okay? Now this is a free response question. So what I want you to do is I want you to pause the video, work the free response question, and when you're done, come back and I'll show you the answers. Okay, welcome back. One of the things that's important for a fundamental theorem of calculus problem part 2 free response question is notation. So the first thing we have to note is, because we're given g of x and we're given 5 is equal to, g of x is equal to this plus 5, I have to write that g prime of x is equal to f of x. Now, in our case, we have this 5 on the outside, but the derivative of 5 is 0, so I get g prime of x is equal to 0 plus f of x, which is just f of x. Okay? This has to be written. And now we can find these values. So g of 6 is going to be 5, because I didn't take the derivative, of 6 to 6 f of t dt. And we know from experience, anytime we raise the limits are the same, that is just 0. So my answer is 5. To find g prime of 6, we have to take the derivative of 5, which we said was 0, plus f of x, or f of 6. So what is f of 6? It's simply 3. So this would be 0 plus 3, which is 3. And now to find g double prime of 6, so g double prime of 6 is going to equal to f prime of 6. So what is the derivative at 6? Well, we're told that there's a horizontal tangent line at 6, so that means the derivative has to be what? 0. So that was part A. So it's probably worth 2 points, 2 or 3 points. I know definitely 1 point for this, and then probably 1 point for finding the other 3 values. On what interval is g decreasing? Well, we know g, any function is decreasing when its derivative is negative. So we'd have to say when g prime of x is less than 0. And where does that occur? So if we're looking at g prime of x, then g prime of x is negative from -3 to 0 and from 12 to 15. So we would write g of x is decreasing, if I can spell it correctly, decreasing from -3 to 0, 12 to 15, because g of x, g prime of x is negative. Remember, you want to avoid using it is negative and pronouns. You want to be specific. So g prime of x is negative. On what interval is it concave down? Well, it's concave down when g double prime of x, which is going to equal to f prime of x, is less than 0. So when is the slope negative? That's the question. When does the graph you're looking at, when does it have a negative slope? And that happens on this interval. So we would say g of x is concave down. Notice how I'm writing complete sentences and I'm answering the question in my sentence. I'm not just saying on the interval from 6 to 15. You have to be specific and you want to write down what you're saying. You don't want to write a paragraph, but you want to be specific. So g of x is concave down on the interval and how do we know that? Do not give a long explanation. We simply know that because g double prime of x is equal to f prime of x and g double prime of x is negative. Okay? Concise and precise, right? Last 2 questions. No, I didn't answer the second question. I didn't leave enough room. I need to find the trapezoidal approximation. So using the trapezoidal approximation, because I'm using set intervals, I can just use the formula for that. And the formula for this trapezoidal approximation, I hope I have enough room, t of x is equal to h over 2 times y1 plus 2 times y, I want to say y0, 2 times y1 plus 2 times y2 plus ... y to the n, because the first and the last are not multiplied by 2. So let's just go ahead and put that into the formula. So h is 3 because we're given that. So this is 3 over 2. And then y sub 0, I'm just reading the values. So at -3, because that's where we're starting, at -3, my first value is -1. And then that'll be 2 times, if I move over 3, then that value becomes 0. Move over 3 more, I get 2 times 1 plus 2 times 3 plus 2 times 1 plus 2 times 0 plus -1. Okay? And when you do all the math for that, you get, I'm just going to write up here, 12. Alrighty? Now, we're going to practice more of this. So I want you to pause the video once again and do these 2 problems, and then we'll come back and talk about it. Okay, welcome back. So remember, I always say think horses, not zebras. And so you may have looked at this and thought of all different kinds of ways you can do it. May have thought, oh, I can make this x over x squared minus 1 plus 1 over x squared minus 1. And you could, except for you would have a hard time integrating that second part. Or you can just remember our favorite F word. I meant factoring. I don't know what you thought I meant. And so once we do that, the x plus 1's cancel, and then I simply have the integral of 1 over x minus 1, which is just the natural log of x minus 1. There is no easy way to do problem 10 other than multiplying it out. So we just got to bite the bullet and multiply that out, and we get x squared. And then on the end, we're going to square that, and we're going to get plus 1 over 4x squared. And in the middle, we multiply these two together and then multiply by 2. We get 1. Okay? And then once we multiply, then I hope you can integrate after that. If not, you might want to come see me. But hopefully you can integrate after that. And that's going to give me negative, I think that's going to be a negative 1/4 x plus c plus c. Don't forget your cookies. Okay. All right. So then when we do a u sub, we just have to remember that du has to be in the expression. And if we have a bound, if it's on a closed interval, we have to remember to change the limits of integration. All righty, boys and girls, I'm going to let you do the next two problems. Pause the video for a minute and then come back and I'll show you the answers. All righty, welcome back. So for this one, what did you make u equal to? I made it equal to 1 plus e to the x, and then du was equal to e to the x dx, which is in our problem, so we're cooking with grease. So we have 1 over du over u, which once again is just the natural log of u, or the natural log of 1 plus e to the x plus c. This one was a little challenging because we have this square root of x, the square root of natural log of x there. But it's okay. We still have to do u substitution, so we're going to make u equal to x squared. So du is equal to 2x dx. So I have an x dx. I need to get rid of that 1/2. So I'm going to make it 1/2 du is equal to x dx. Now I have to replace my limits because now I'm in u. So u of 0 is simply 0 squared, still 0. U of the square root of the natural log of x is the square root of the natural log of x, quantity squared, which I think is just simply natural log of x, right? So now we integrate from u, from 0 to the natural log of x. U is x squared, so this is e to the u, and I have 1/2 on the outside. That's a pretty straightforward integration. It's just e to the u. So this is 1/2 e to the u evaluated from 0 to the natural log of x. So e to the natural log of x is x minus e to the 0, which is 1, and times the half from before, and that is my answer. Okay, let us recall inverse trig. Notice I only listed 2 because these are the only 2 that generally show up on the AP exam, and generally it's the inverse tan. I haven't seen inverse sine in a long time, but this will be the year. Okay. Once again, pause the video, and you guys try these, and then we'll come back and figure it out. Okay? Welcome back. This one was a little tricky, but we had to notice, and I kind of gave you a hint when I told you we were going to use inverse trig. We have to make u equal to e to the x. So then u squared is equal to e to the 2x. You see where I'm going with that? And then du is equal to e to the x dx. So this becomes, I'm going to replace this with du over 1 over u squared. And once we have that, then we just know that that is the tan inverse of u. And the tan inverse, and u is e to the x. Interesting. And finally, we have to do another u substitution. What should I make u equal to? Well, if I make u equal to arc sine x, then du is equal to 1 over the square root of 1 minus x squared dx. That's in my problem. Let's change our limits of integration. So u of 0 is arc sine of 0, which is 0, and u of radical 2 over 2 is the arc sine of radical 2 over 2, which I think is pi over 4. So I have the integral from 0 to pi over 4 of u. So that is 1/2 u squared integrated from 0 to pi over 4. So that's 1/2 pi squared over 16 minus 0. So my answer is pi squared over 32. And I think that's it, boys and girls, for today. So what I want you to remember is the fundamental theorem of calculus and its criteria. I want you to be able to use the integration of different integration techniques, and then always remember to try the simplest answer first.